Now, let us see how to create the model of a 3-span continuous beam. In this part, we'll see the modeling, and then analysis and design can be seen in the next part. So click New, File Name, say let it be continuous beam. So let it be continuous beam 1. Let the location be Essential STAADworks. So choose appropriate location and file name. Click select the units as metric. Click Create. So click the structure wizard, in which you'll be having frame models, in which you'll be having continuous beam model. Double click on this. Say let the continuous beam be of spans AB equal to 4 meter, BC equal to 5 meter, and CD equal to 3 meters. So 4, 5 and 3, so 12. So total length will be 12, and number of bays. So I'm going to use 3 bays, so type 3. Then click here to define the bay length. So first bay of length 4, second bay of length 5, and third bay of length 3. So 4 plus 5, 9 plus 3, 12. So total length should tally. In case even if they make a mistake here, then it will tell. Say for example, if I give 2 meters, then if you click OK, it will say the base segments does not add up to the length. So please check segment value. So we need to check and then correct it as 3. Okay. Then click OK. Then click Apply. So you have 3-span continuous beam model. A line model is created. Go to File, Merge Model with STAADPro model. Yes. OK. So now we see a 3-span continuous beam. See the front view by clicking View, Front View. Go to Label Settings. I want to have node numbers, node points, beam numbers, and node values to be displayed. Click Apply. So now the beam number is 1, this beam number is 2, and beam number is 3. Node numbers 1, 2, 3, and 4. Say we call this as connectivity. Say member 1 is connected between nodes 1 and 2. Member 2 or beam 2 is connected between nodes 2 and 3. And beam 3 is connected between nodes 3 and 4. In STAADPro, they call this as member incidences. That is, a member is connected between which node? Yeah, member 1 is connected to 1 and 2, 2 between 2 and 3, and 3 between. These are called member incidences, as we see in the command file after generating the model. Now we are going to give the dimensions property. Say this is 4 meter span, this is 5 meter span. So let us give 230 by 450 mm depth here. The same can be used here. And 230 by 300 mm will be sufficient for this span. So go to Properties, click Define, Rectangle. Say the depth will be of 0.45, width will be 0.23, add, and another property will be 0.3 and 0.23, add, close. So I'm going to use this property for the first 2 beams and this property for the third beam. So we need to highlight this property, select these 2 members. So you can select these 2 members by pressing Ctrl. To select more than 1 member, we need to use Ctrl. So select this, assign to selected beams, click Assign, click Yes. So R1 will be assigned to members 1 and 2. Then click this property, select this beam, click Assign to select beams, or see whether Assign to selected beams is highlighted, then click Assign, click Yes. So the property R2, that is reference to of rectangle 0.3 by 0.23 metal is concrete. Now to ensure whether this line model has been converted to solid model, we can go to View option, click 3D rendering, and we can enlarge this and see. So this first 2 of some cross section, and the last member is the some other cross section. So that we can verify. Yes. Now we are going to give the support conditions. say let the left support be fixed and all the other three supports be hinged. So go to supports, create, fixed, add, create, pinned, add. Now select this fixed support, select left node which is fixed, click assign, click yes. And these three nodes are hinged. So we need to select these three. So first unselect this selected one. So by clicking outside, then press Ctrl to select node 2, node 3 and node 4. So before that you select the hinged support because the support 2 is fixed. So it's hinged support. Now select the nodes 2, 3 and 4. Now see whether assign to selected nodes is highlighted, then click assign. Click yes. Now we can see the continuous beam, a 3-span continuous beam with left end fixed and other 3 ends hinged. So to see all the supports, just go to view option, go to display options, click assign dialogs, show all labels. This will show only the labels which are selected recently, now or currently. So now click this and click apply, click OK. Now we can see all the supports. So this is a fixed support, these three are hinged. So we have developed the model of a 3-span continuous beam with support conditions. The next is loading. So let the span 1, this beam be loaded with UDL, this with uniformly varying load, and here there may be a central point load. Let us assume a central point load. So let us see how to give the loadings. So go to load case details, click add, and close. Now select this load case, click add. We are going to give member load. So click member load. First portion is UDL, say let it be minus 25 kilonewton per meter. Click add. And the second span is uniformly varying, so click linearly varying. We have two types. You may give either trapezoidal loading like this or this triangle load. So if you want to give this loading, select this. If you want to give this type of loading, you need to select this. So let us give this W3 and let it be minus 30. That is, intensity at the center will be 30 and at the ends it will be 0. So click add. Then let us give a concentrated central point load in the span, third span. Say let it be minus 40 kilonewton acting at distance of 1.5 meters. So since the span is 3 meters, 1.5, click add, close. So these loads will be added here. Now these have to be assigned to the members. So click uniformly distribute load, select span 1 or beam 1, click assign to selected beams and click assign. So this load will be same. Now want to apply this uniformly varying load or linearly varying load to span, second span. So click this, click assign to selected beams, click assign, click yes. So triangular load, and the last span consists of point load. So select this and ensure that the other beams are not selected, because if both the beams are selected, then the loading may be loaded over both the spans. So we need to ensure whether the beam over which we want to give the load is selected. So click this beam, click this load, so assign to selected beams, click assign, click yes. Now if you want to see the loads, just click view loading diagram. So you can see, say span AB is subjected to UDL of 25 kilonewton per meter and span BC is subjected to uniform varying load of 30 kilonewton per meter at the midpoint and 0 at the ends, and a central point load of 40 kilonewton in the span CD. Now the loading has been assigned. So with this we will stop this part.